As of May 13, 2026, Uruguay's national emergency system, the Sistema Nacional de Emergencias, known as SINAE, has confirmed that 652 people have been forcibly evacuated from their homes across the country, with 346 of those individuals sheltering in evacuation centers inside the Montevideo capital city. Area alone, all of them displaced not by earthquake, not by volcano, not by the sea rising against the shore, but by a cold that arrived 6 days ago with heavy rainfall, sustained winds, and temperatures plunging far below what this coastal nation of 3.4 million people has prepared for in the early days of May, before winter has even officially begun. If you rely on this channel for science-grounded and verified data and explained with honesty, subscribing ensures that none of this reaches you late. This work depends on the audience that values it. Every figure in this script was drawn from official scientific and governmental sources: GADAX, WHO PAHO, Uruguay's National Emergency System SINAE, NOAA's Climate Prediction Center, and peer-reviewed meteorological research. But official sources are not infallible, and neither is the human process of reading them. Before any decision is made, whether personal, professional, or otherwise, verify independently through the official channels. The sources are listed, the data is public, the responsibility to check belongs to all of us, but that is not even the complete picture. Because what is happening across Uruguay right now, what drove 346 men, women, and children in Montevideo alone onto gymnasium floors and police academy cots, what shattered 85 houses across the departments of Rivera, Salto, Treinta, White Res, Durazno, and San. What put 3,291 people countrywide into a state of documented impact is not simply a storm. It is the surface expression of something far older, far larger, and far more connected to the behavior of the entire Southern Hemisphere's atmosphere than any single news bulletin has yet explained. This cold spell did not begin on May 8, 2026. It began in Antarctica, and the mechanism that carried it northward across thousands of kilometers of South Atlantic water and Argentine pampas before slamming into one of South America's most densely populated capitals is one that climate scientists are now watching with increasing unease, because what moves the air over Uruguay today sends its signal into systems that govern rainfall patterns, ocean temperatures, and extreme weather frequency across the entire planet. To understand what is actually happening, you have to understand the wind. Uruguay is a nation without mountains. This is not a minor geographical detail, it is the single most consequential fact about how weather moves across this country. There is no ridgeline, no cordillera, no natural barrier of any kind between the southernmost reaches of Antarctica and the city streets of Montevideo. The flat terrain of the Argentine pampas forms a vast, unobstructed corridor hundreds of kilometers wide, and when a cold front descends from the polar south, nothing slows it, nothing deflects it. The wind simply accelerates across the grasslands and arrives at Uruguay's doorstep with the full force of the pressure gradient behind it. Meteorologists call this wind the Pampero. Aviation safety databases classify it as a burst of cold polar air from the west, southwest, or south that takes the form of a squall line, brings a marked and sudden drop in temperature after its passage, and is most common in the Southern Hemisphere's winter months, principally between May and August. What the Pampero delivers is not gradual. It does not give the populations in its path time to adjust. A warm afternoon becomes a dangerous night within hours, and anyone without adequate shelter when the squall line arrives is in immediate physiological danger. The system that struck Uruguay on May 8, 2026, carried all the characteristics of a significant Pampero event, compounded by sustained heavy rainfall and thunderstorms. Conditions that continued to affect most of the country for 6 consecutive days leading up to the date on which this script is being recorded. Think about what 6 days means in human terms. 6 days of heavy rain soaking through the walls of vulnerable housing. 6 days of strong winds tearing at rooftops in the departments of Rivera and Salto. 6 days of very low temperatures settling into the bones of people who had not anticipated winter arriving in the second week of May. 85 houses confirmed damaged. 85 families whose 4 walls are no longer adequate protection. 6 displaced families relocated entirely, and 652 people, 652 human beings in evacuation centers tonight. The 346 people sheltering in the Montevideo capital city area are not numbers. Montevideo is a city of approximately 1.4 million people, nearly half of Uruguay's entire population concentrated in a single metropolitan area on the northern shore of the De La Plata estuary, where the river opens toward the South Atlantic. The city sits at 34 degrees 54 minutes south latitude, elevated just 43 meters above sea level at its central point, fully exposed to the winds that push in from the south and the southwest. The neighborhoods closest to the waterfront, Barrio Sur, Palermo, Punta Gorda, are home to working families, retirees, and a homeless population that the Uruguayan Ministry of Social Development documented in 2024 as exceeding 2,700 individuals, the vast majority concentrated in the capital. These are the people who felt this storm first and felt it hardest. Think about what it means to wake in a makeshift shelter as rain drives horizontally against every exposed surface, with temperatures that have dropped well below what early May in Montevideo should produce, a month when average nighttime lows sit around 2 degrees Celsius and daytime highs average 6 degrees. When the Pampero is running and the thermometer falls, those averages become irrelevant. The cold does not negotiate with averages. The people of know this. The residents of Rivera know this. In the department of Salto, on the western edge of Uruguay where the Uruguay River forms the border with Argentina, families who live in low-lying areas adjacent to watercourses experience the compounding disaster of cold temperatures combined with flooding, the dual assault of a weather system that brings both the freeze and the inundation simultaneously. These are not abstract disaster zones. Salto is a city of approximately 130,000 people. Further south along the Uruguay River is home to roughly 80,000. These are communities with hospitals, schools, markets, football pitches, Sunday afternoon families. When SINAE reports that Rivera, Salto, Treinta, White Res, Durazno, and San are all among the affected departments, what that means in human terms is that this event did not target a small region. It struck a diagonal line across the entire country from the northern interior to the southwestern plains, and it left behind 85 damaged houses, 6 displaced families, and 3,291 documented affected people as its confirmed human record as of May 13, 2026. And here is where this account becomes genuinely significant, because this is not the first time. This has already happened before, and the record of it is preserved not in geological stone but in meteorological archives that tell a story of escalating frequency that scientists choose their language carefully around, and that careful language is itself the warning. Cast your attention back to June 2025. Less than 12 months before the present event, Uruguay was struck by a polar air mass extending directly from Antarctica, a system so anomalous for its season that it killed at least 6 homeless people across the country and prompted President Orsi to invoke rare executive emergency authorities that empowered police and officials to forcibly remove homeless people from the streets. Authorities opened 32 new warming centers and converted public gyms and a police academy into evacuation facilities, preparing approximately 1,000 emergency beds. In the Montevideo capital, meteorologist Mario Bidegane confirmed that on June 30, 2025, the city recorded its lowest maximum daytime temperature since 1967, 8 degrees Celsius at the warmest point of the day, the lowest since 1967, 58 years of temperature records, and June 30, 2025 broke through all of them to claim the coldest daytime maximum in over half a century. Meanwhile, Argentina's capital Buenos Aires dropped to -9 degrees Celsius on the same cold front, the lowest in 34 years. Snow fell in parts of the Atacama Desert, the driest desert on the planet, for the first time in a decade. Climatologist Raul Cordero from the University of Santiago told Agence France Presse, "It is not so common for these cold air masses to extend so far north, so we cannot rule out that this is also caused by climate change." Meteorologist Arnaldo Zuniga added, "The frequency of heat waves has tripled, whether in summer or winter, not only in the southern cone but throughout the world." Now reach back further, to May 2022, when the South American cold wave that would eventually claim at least 37 lives across Bolivia, Argentina, Peru, Uruguay, and Paraguay began its formation. The Uruguayan Institute of Meteorology issued an alert on May 30, 2022, for the arrival of cold air masses across the southwest, center, east, and northeast of Uruguay, warning of temperatures descending to -7 degrees Celsius in interior departments. In the central southern cities of Uruguay, the cold records established over decades of climatological monitoring reached down to -7 and -8 degrees Celsius, that is 17 to 19 degrees Fahrenheit. Uruguay's interior can, under extreme polar intrusion conditions, become as cold as a winter morning in Boston or Chicago, and it does so without the insulated housing, the centralized heating infrastructure, or the cold weather preparedness culture that Northern Hemisphere cities have spent generations developing. The 2022 South American cold wave was documented by researchers and climate agencies as having been influenced by global warming through the mechanism of unbalanced air masses, the disruption of the atmospheric pressure systems that normally keep cold polar air corralled at high southern latitudes rather than allowing it to surge northward into the subtropics. This is not a hypothesis. This is documented in the scientific record. The mechanism works as follows. The Southern Hemisphere's polar vortex, the broad circulation system that spins over Antarctica and normally contains the coldest air within its boundary, is sensitive to temperature differentials between the polar region and the warmer latitudes to the north. When that differential shifts, when the stratospheric conditions weaken the vortex's containing structure, cold air escapes in what meteorologists call a polar air outbreak. It descends across the Argentine pampas. The Pampero wind carries it northeast, and Uruguay, sitting flat and open at 35 degrees south latitude, receives the full system with nothing to break its momentum. The question the atmospheric science community is now asking is not whether these outbreaks are happening. They are happening. The question is whether they are happening more frequently, more intensely, and at less seasonally appropriate times than the historical baseline suggests they should. On that question, the data from NOAA's Climate Prediction Center as of April 2026 is precise. ENSO neutral conditions are currently present, with La Niña having recently dissolved. NOAA's official forecast gives a 61% probability that El Niño will emerge in the May to July 2026 window and persist through at least the end of the year. Independent meteorological analysis published in the weeks leading into May 2026 describes what is forming in the tropical Pacific as a potential Super El Niño, a warm phase event of sufficient magnitude to alter precipitation and temperature patterns across the entire Southern Hemisphere. The transition from La Niña to El Niño is itself a period of atmospheric instability, a moment of reorganization in the global circulation when weather systems that would normally be suppressed or moderated find pathways they would not otherwise find. The cold spell striking Uruguay in the second week of May 2026 is arriving precisely at this moment of transition during the window when the old oceanic cold signal is fading and the new warm signal has not yet stabilized the atmosphere into its El Niño configuration. The system is not inactive. It is accumulating the conditions for a pattern that scientists are watching with close attention across multiple monitoring agencies. But there is a second connected system that belongs in this account, and it operates not in the Pacific Ocean but in the atmosphere directly above the Southern Hemisphere's stratosphere. Extratropical cyclones, the damaging storms that occasionally sweep across Uruguay and the broader southern cone with winds that have, in documented historical incidents, reached 200 km per hour in 2005 and 172 km per hour in 2012 are products of a dynamic between polar pressure systems and mid-latitude warm air. The same atmospheric boundary that separates cold Antarctic air from the warmer subtropics is the boundary along which these cyclones develop. When that boundary sharpens, when the contrast between polar and subtropical air masses intensifies, as it does during Pampero events and as it does during the La Niña to El Niño transition, the potential for storm formation increases. The cold spell and the broader meteorological pattern are not separate stories. They are the same story told in different frequencies, and the instruments measuring both are showing elevated activity at the same time. There is a family in Salto tonight whose house is among the 85 confirmed damaged across Rivera, Salto, Treinta, White Res, Durazno, and San. Imagine what it means to live in Uruguay's western river department with the Uruguay River running past your city, knowing that the same storm system that has already dropped the temperature to dangerous levels is also saturating the catchment areas upstream in Brazil and Argentina, where the river draws its volume. The Uruguay River has flooded before. It has flooded with enough force to displace 11,000 people in the departments of Artigas and Salto in previous events. The residents of these cities carry that knowledge in their body memory even when the official warnings have not yet arrived. A father closing the shutters against horizontal rain while his children sleep knows, without needing a meteorologist to explain it, that the sound of water rising beneath the floor is not the same as the sound of water falling from the sky, and that both sounds are speaking to him tonight. In Montevideo's evacuation centers, the gymnasiums, the converted public facilities, the 1,000 emergency beds that were mobilized after the June 2025 cold event established the protocol, the 346 people displaced in the capital area are beginning the particular difficult calculation that displaced people everywhere make, which is the calculation of how long the emergency will last and what will be waiting for them when they return. GDAX confirms that over the next 72 hours from the May 13th reporting date, no more severe weather is forecast over the whole of Uruguay. That is a piece of forward-looking information that belongs here. The immediate meteorological threat appears to be receding, but what does not recede is the housing damage. 85 houses across 6 departments are structurally compromised. Those families do not return to intact homes. They return to what the storm has left, and they begin the slow and often under-resourced process of reconstruction in a country that WHO PAHO has documented in the disaster monitoring record alongside the national emergency system precisely because these events require coordinated humanitarian response, not simply temporary shelter. The 3291 people countrywide who have been classified as affected, a number that includes both evacuated individuals and those impacted in their homes through flooding, structural damage, or loss of services, represent a population roughly equivalent to the entire population of a Uruguayan small town. Picture the entirety of a functioning community, everyone who walks its streets, attends its schools, works in its shops, visits its medical clinic, and then imagine all of them simultaneously requiring assistance, simultaneously displaced or impacted, simultaneously dependent on the coordination of a national emergency system that is designed to handle these events, but that is managing this one while simultaneously watching the atmospheric forecast for what comes next. What the official data actually shows is this: the event that began on May 8, 2026, with heavy rainfall, strong winds, and very low temperatures across most of Uruguay arrived 6 weeks before Uruguay's meteorological winter even formally begins. June is typically the month of lowest average temperatures in Montevideo, with historical records showing the coldest daily maximum since 1967 occurring on June 30th of last year. But the May 8th system struck the country at a time when its population, its infrastructure, and its emergency response systems were still calibrated for autumn conditions, not for the kind of Pampero-driven cold intrusion that normally arrives later in the season. The seasonality of this event is itself a signal. Uruguay's climate, classified under the CPEN system as a humid subtropical climate with mild winters, carries an expectation of temperatures in May that sit comfortably between 10 and 19 degrees Celsius. A cold system with sufficient intensity to force 652 evacuations and damage 85 structures in May is not inside that envelope of expectation. It is outside it, and the frequency with which events outside that envelope are occurring: May 2026, June 2025, June 2022, and the earlier documented history of cold wave impacts in this country is the data point that the scientific community is assembling into a pattern. The geological record of Uruguay's climate does not preserve individual cold spells the way it preserves earthquakes or volcanic eruptions. but it preserves the atmospheric circulation patterns that produce them in sediment cores, in ice core data from Antarctica, and in the long-term instrumental record that Uruguayan meteorological stations have been generating for more than a century. That record tells us that the Pampero has always existed, that cold waves have always reached Uruguay in its winter months, that this country's flat geography has always made it vulnerable to polar air intrusions in a way that its mountainous neighbors to the west are not. What that record does not tell us, what it cannot yet tell us with the certainty that prediction requires, is whether the frequency and the seasonality of these extreme events is shifting in a statistically significant direction, or whether the events of June 2025, the events of the 2022 South American cold wave, and the current May 2026 episode represent the normal distribution of a climate system that has always had its outliers. That is the question the instruments are asking. And the instruments, to be clear, are not coming back with a simple answer. This is not a hypothesis, the uncertainty itself is documented in the scientific record. What climate scientists from the University of Santiago, the Uruguayan Institute of Meteorology, NOAA, and the World Meteorological Organization have been saying across the accumulating event record is not that they are certain extreme cold is increasing, but that the mechanisms by which global warming disrupts atmospheric circulation, the weakening of the polar vortex boundary, the alteration of pressure gradients between Antarctic air masses and subtropical warmth, the sensitivity of the ENSO cycle to rising ocean temperatures all point in a direction that makes events like the one currently unfolding in Uruguay more probable, not less, over the coming decades. Minutes are not hours, and in this context that difference is everything. When the Pampero arrives at a velocity sufficient to form squall lines across Uruguay's unshielded plains, the transition from bearable to dangerous does not take days, it does not take hours. It takes the time it takes for a cold front to pass overhead, and then the temperature on the other side of that front is a different number than the temperature that preceded it, and the people caught in that transition without shelter are in a physiological situation that the human body cannot negotiate with indefinitely. The homeless population of Montevideo, the more than 2,700 individuals documented by the Ministry of Social Development in 2024, the majority of them in the capital understand this with a clarity that no meteorological briefing can fully convey, because they understand it in their skin and in their lungs and in the specific numbness that sets in when wind chill takes an already cold air temperature and subtracts from it the last thermal buffer between a human body and hypothermia. There is a young man named Lucas Bill here, 19 years old, who was documented by Associated Press journalists in the Montevideo Evacuation Center during the June 2025 cold event. He sat wrapped in a blanket on a vinyl mattress on the gymnasium floor with his puppy, Alaska, and he said, "The worst time of winter is dusk, when the cold starts to set in and your body can't take it anymore." He was speaking about June 2025. He is not quoted in the May 2026 emergency record, but he and the thousands of people like him in Montevideo's streets and informal settlements are the human population at greatest risk in this and every subsequent cold event that breaks early, arrives without adequate warning, or exceeds the severity that the shelter system was sized to accommodate. When the June 2025 event required 32 new warming centers and the conversion of a police academy into a sleeping facility, those resources were mobilized because the scale of the crisis exceeded what normal operations could absorb. The question that SINAE, WHO PAHO, and Uruguay's government must now answer is whether the current May 2026 event has stretched the system to the same threshold or beyond it, and whether the 652 evacuees currently in centers represent the full count or the opening number. The global system context matters here because it determines the probability surface for future events. NOAA's Climate Prediction Center has confirmed that El Niño conditions are expected to emerge in the May to July 2026 window with a 61% probability. When El Niño dominates the tropical Pacific, it alters the position and strength of the South American monsoon, the circulation patterns over the South Atlantic, and the frequency of cold outbreaks in the southern cone. Research from past El Niño episodes, particularly the strong events of 1997 to 1998 and the documented extreme of 2015 to 2016, shows that El Niño's influence on Uruguay is complex, bringing increased rainfall to some regions while shifting temperature patterns in ways that do not always follow simple predictions. What the emerging Super El Niño of 2026 will deliver to Uruguay's winter season cannot yet be stated with certainty. But the atmospheric scientists monitoring subsurface Kelvin waves in the Pacific, measuring the collapse of the La Niña cold pool, and tracking the westerly wind bursts that are recharging the warm phase of the ENSO cycle, they are not looking at a system that is relaxing. They are looking at a system that is recharging. Uruguay is a country of 3-4 million people. It has no Himalayan shield. It has no Rocky Mountain backbone. It's on the eastern edge of the De La Plata estuary at the hinge point between the South Atlantic and the interior of the continent, and every major atmospheric system that crosses the southern cone passes through it or over it or around it in a way that leaves a mark. The 85 damaged houses in 6 departments are a mark. The 3291 documented affected people are a mark. The 652 people in evacuation centers as of May 13, 2026, 346 of them in the capital of Montevideo, 306 of them in interior department centers are a mark. And the mark that concerns scientists from Santiago to Montevideo to Geneva are reading is not just the number of people displaced by this particular event. It is the pattern of marks accumulating across the years, each one falling at a time or with an intensity that the historical baseline did not predict, each one requiring the national emergency system to mobilize resources, each one requiring WHO PAHO to issue natural hazard monitoring reports, each one leaving behind not only damaged houses but a population that has experienced one more event outside the envelope of what it expected its climate to deliver. The system is not inactive, it is accumulating. The cold that swept Uruguay on May 8, 2026, carried with it the momentum of Antarctica's polar air, the unobstructed corridor of the Argentine pampas, the vulnerability of a flat-terrain nation without natural weather barriers, the atmospheric instability of the La Niña to El Niño transition, and the compounding frequency of anomalous cold events in a region where the relationship between global ocean temperatures and polar air containment is being actively re-examined by the world's leading atmospheric scientists. Every one of those factors was present in the data before the storm arrived. Some of them are still present now, as the 72-hour forecast offers temporary relief but makes no promises about the weeks and months ahead. Uruguay's meteorological winter officially begins in June. What May has delivered is a preview and previews. In atmospheric science are not warnings the way a press release is a warning. They are the thing itself, arriving slightly ahead of schedule, carrying full force, and leaving behind the record of exactly how much damage a single weather system can produce when the conditions align, what the Smithsonian Global Volcanism Program monitors in magma, what the USGS measures in seismic waves, what NOAA tracks in ocean. Temperature anomalies, all of it is part of the same planetary machine. Earth is a single interconnected system, and the Antarctic air mass that drove the Pampero into Uruguay in the second week of May 2026 did not originate in isolation. It originated in the behavior of the polar atmosphere above a continent that has been losing ice at a rate that changes the thermal dynamics of the Southern Ocean, which changes the temperature gradient between Antarctica and the subtropics, which changes how easily polar air can breach the atmospheric boundary that normally contains it. These connections are not speculative. They are the subject of active, peer-reviewed research at institutions including the University of Santiago, where climatologist Raul Cordero stated plainly in the context of the June 2025 event that polar air masses extending this far north at this intensity are not historically common and that climate change cannot be ruled out as a contributing mechanism. The floor of this story is harder than it looks. Beneath the 652 evacuees and the 85 damaged houses and the 6 departments under impact, beneath the gymnasiums and the vinyl mattresses and the hot meals and the cold gymnasium air, beneath the formal language of the GDAX report and the WHO PAHO Natural Hazard Monitoring Bulletin, there is a country learning what it means to face weather events that its population, its infrastructure, and its emergency response architecture were not fully designed to handle. There is a government that mobilized resources last June for an unprecedented cold event and is mobilizing resources again this May for a cold event in a month that does not historically require this level of response. There is a national emergency system that is issuing reports with the precision that official systems require and that cannot answer the question its own data keeps asking: is this the new normal or is this still the edge of the old variability? The Uruguayan Institute of Meteorology does not know the answer to that question with certainty. Neither does NOAA. Neither does the World Meteorological Organization. What they know, what the official data actually shows, is that polar air outbreaks in the southern cone are a documented, recurring phenomenon driven by a mechanism that global atmospheric change is plausibly intensifying. What they know is that Uruguay has experienced cold events requiring emergency responses in May 2026, June 2025, and the winter season of 2022. What they know is that 652 people are in evacuation centers tonight in a country where the average nighttime temperature in May is supposed to sit at 10 degrees Celsius, and those 652 people are there because the temperature was not 10 degrees Celsius, and the wind was not gentle, and the rain was not brief. 65 million years ago, when the mass extinction event that ended the Cretaceous period reorganized the biological history of this planet, it was a change in atmospheric temperature and composition that preceded the collapse of ecosystems, not the impact event alone, but the years of global thermal disruption that followed. The geological record is full of the evidence of what happens when planetary systems shift beyond the parameters within which life had organized itself. This is not a metaphor for what is happening in Uruguay. It is a reminder of the scale against which individual weather events register. The 652 people in evacuation centers in Montevideo tonight are registering on a scale that the planet does not notice. But the planet systems are registering on a scale that the people of Montevideo are beginning, event by event, year by year, to notice, and what they are noticing is that the cold is arriving before they are ready for it, with more force than the calendar suggested it should carry, and with a frequency that makes the word unprecedented harder and harder to use without immediately following it with the word again.